Hi everyone, this is another one of the computer videos, and this video is about how a computer works. In this video I'm going to talk basically about the fundamentals of how a computer works and the different parts of the computer and their functions. The CPU and motherboard. The motherboard is the green flat disk and has many things attached to it. It provides power to everything attached to it. One important thing attached to it is the CPU, or the Central Processing Unit. The Central Processing Unit doesn't actually store data or doesn't actually allow applications to be run, but it just processes information that it gets from different areas of the motherboard. For instance, if there's a storage compartment on the motherboard, it gets data from the storage, such as the RAM. It gets data from the RAM, and it processes this and then gives it back to the storage, and this process is discussed in the next slide. The control unit. The control unit directs or controls the rest of the computer system, but does not carry out any unique functions of its own. Think of a GPS, for instance. All it does is takes the information you give it, makes meaning out of it, and gives the driver directions. Similarly, the control unit takes information that is inputted in, makes sense of it, and tells the other parts of the CPU what to do. Here is a computer drawing of what the CPU looks like and how it is split up. I will be referring to this drawing many times throughout the video. The second part of the CPU is the arithmetic or logic unit. This unit is responsible for mathematical operations such as adding, subtracting, multiplying, or dividing, which is the arithmetic part of the unit, and it is responsible for logic operations such as comparisons, matching, or merging of data. There can be comparisons between numbers, letters, or symbols, and the conditions for the comparisons are equal to, less than, greater than, less than or equal to, and greater than or equal to. The arithmetic and logic unit basically takes information that is input into the computer and acts upon that information by using the mathematical operations or the logic functions, and outputs the task that is required. For instance, its logic functions, such as comparisons, can allow the computer to carry out tasks such as determining who has won a game based on who has more points, or how many days are left until your package is delivered. In addition to the CPU, there is also storage or memory. Storage or memory basically holds data that is waiting to be released to something such as the CPU, which uses and analyzes the data to perform a certain task. There are two main kinds of storage, primary or secondary. Secondary storage stores data that is removable from the computer, and the data is permanent and is usually in the form of a disk or hard drive. This means that you can take it anywhere and use it in different places. On the other hand, primary storage, or memory, engages heavily with the CPU and is the computer's main memory. It stores data that is waiting to be processed by the computer and analyzed by the computer to perform a certain task. Primary storage is located on the motherboard and cannot be detachable and carried around and taken to different places. There are many different names that primary storage or memory are called by, such as main memory, which I've already referred to, RAM, which is random access memory, or even main storage. All of these are used interchangeably. Registers are another part of the computer. These are temporary storing locations that are located near the arithmetic or logic unit. Registers do not deal with memory, but instead with instructions and data. The control unit tells the registers where to send and for how long to hold the data or instructions. Registers also act as a kind of buffer zone between the memory unit and the arithmetic and logic unit. Registers are especially different than the memory and storage unit because they compute arithmetic or logical functions much quicker than any other storing areas. There are different types of registers that each have their own distinct role. For instance, an accumulator holds the answers to the computations made by the arithmetic or logic unit. A storage register holds data that is going to be sent to the memory of the computer system. An address register has data regarding where a certain instruction is kept in the memory. And finally, the general purpose register is just that, a register which stores many different things for many different purposes. Now you may ask, How do all these pieces work together? Well, when an input device, such as a keyboard or a mouse, tells the computer to do something, the control unit takes the instruction to the primary memory. Then, when the arithmetic or logic unit is ready, the control unit sends the instruction or data from the primary memory to the arithmetic or logic unit, where the data is processed and analyzed. Then, the instruction is sent back to the primary memory, where the result of the computation is kept until it is ready to be sent to an output unit, such as the printers, monitors, and screens. Let me ask, how does the control unit keep track of where the memory is kept in the primary memory? Well, the control unit finds the instruction that is put into the primary memory by using the instruction's register address. The computer also uses an instruction's register address in the arithmetic and logic unit during computations. For instance, the arithmetic or logic unit may say that the data with the address number 5 has to be multiplied with data with the address number 2. This makes the computations much more easier for the arithmetic or logic unit. Anyway, this whole process by which the data travels is called the machine cycle, and each step happens very quickly, so it seems that they are all happening simultaneously when they're actually happening at 1/1 billionth of a second for each step, and this delivers the result. I hope you learned a lot about computers and how data travels through them and how a task gets completed by the computers and the different parts of the computers. And these are just some of my citations I used to research for this video. Here are some more citations, but for and here are the final lot of citations. I again hope you enjoyed this video, and subscribe if you want more videos like this, because I'm working on a series of computer videos, and you can watch the previous videos to learn more about computers. I give an introduction to computers and the speciality of computers. And yeah, thanks for watching.